Hello, my name is Daphne, and today I'll present to you the paper Lena, a dynamic data visualization for slow exercising feedback. This paper is written by myself, Evianne van Hartingsveld, Mes Birkebak, Steven Vos, and Karine Lallemand. The popularity of running has increased over the last few decades, resulting in it being one of the most popular recreational sports in the world. Running is characterized by its low threshold to start and its attractiveness for a wide range of people. This heterogeneity among runners is especially represented in terms of age, gender, motivations, and abilities. In line with the popularity of running, there has been an exponential increase in the development of monitoring devices to support runners in their training. Running apps and wearable technologies, such as sport watches and activity trackers, enable quantified data tracking. Feedback is then given through graphs and numbers, aiming at increasing performance during the training. However, in these attempts, the design space tends to be rather homogeneous. And although this type of feedback offers people a quick glance on their running performance or patterns across time, it does rely on a limited view on the running experience, which already starts before and expands after the running session itself. A recent study suggests, for example, that people have high feelings of pride and satisfaction after running, but these positive emotions fade away quickly. An artifact which allows for longer reflection and exploration of running data might support people in experiencing these positive feelings for a longer period, going beyond performance-focused feedback. In this paper, we will explore how to use a shape-changing interface to represent dynamic running data, while drawing on the work of Stuzak et al., by further exploring how to prolong rewarding feelings experience right after a running session through a slow feedback mechanism. To explore how the concept of a slow feedback mechanism could materialize in a data visualization artifact, we invited 23 design experts to participate in a 20-minute online survey study. We used the interaction vocabulary, which is a dedicated and suitable tool to collect insights in a structured manner. The participants were asked to evaluate each pair of opposite words and to indicate which one of the two attributes would better contribute to translate the intended aesthetics of interaction in the design. The table shows that 8 attributes were associated with a slow feedback mechanism for running in the context of interaction design. Slow, fluent, delayed, spatial proximity, approximate, powerful, targeted, and apparent. After the expert study, the authors conducted an interactive and explorative design process informed by the most important attributes for a slow feedback mechanism: delayed, powerful, slow, targeted, and approximate. We started with several form and material explorations. First, we explored materials that could shape change as described by Rasmussen et al., with a focus on investigating possibilities, understanding the constraints of some materials, and getting inspiration to translate running route data. Based on the explorations, we built 4 intermediate lo-fi prototypes to reflect on different characteristics, namely levels of density, the type of physical change in surface, and different forms of restrictions in the visualization of a run, leading to the final design of Lena. Lena is a shape-changing art piece, presenting physicalized running routes over a delayed period of 1 or 2 days. Over this time, some of the pins on Lena are pushed out one by one, creating a data visualization pattern corresponding to the mapping of the last running route. The length the pin comes out represents a specific effort given at that point on the route. The metric related to the effort can be chosen by the user. Lena adopts an aesthetics perspective to spark positive feelings towards running through a slow feedback mechanism and aims to trigger longer satisfaction feelings of the previous run. Lena works complementary to existing applications. First, the user tracks their running route with an application like Strava or Runkeeper. When the run is finished, Lena is activated and starts to change, but takes 1 or 2 days to fully develop. The user can then decide what part of the run they want to keep by pushing back some of the pins. This way, we integrated a direct and indirect level of control of the interaction with Lena. The overall architecture of Lena consists of a wooden frame supported by a wooden plate at the back, which serves as a base for an X and a Y axis. 2 stepper motors are placed on top of this wooden frame, controlling the position of a linear actuator. In the current prototype, the transformation from the detected route via an external platform to the visualization of the route on Lena is not automated. To solve this, a web page was created where the pins could be altered by the researchers. For a more elaborate explanation on this, we refer to the published paper. We deployed Lena in 3 households for a 3-week field study with each participant. We combined several pre- and post-interviews conducted at the participant houses with a diary study. The study consisted out of 3 parts: an introduction interview, logging daily experiences, and a debriefing interview of Lena. In the introduction interview, we invited the participant to describe their running behavior and devices currently used to support training. We aimed at a better understanding of their lifestyles, running routines, motivational factors, and the role of technology in a running session. To report on daily experiences with Lena and associated feelings, the participants were asked to log their observations by sharing a voice message on the instant messaging application WhatsApp and a picture of the current shape of Lena. After the in-city deployment period, we conducted a semi-structured debriefing interview. We inquired about how the participants experienced Lena across time, how they interpreted this experience, and how it potentially influenced their behavior and attitude. The participants were recruited via a local running group page or personal pages of the researchers on social network. All participants identified as women, but were diverse in age, household compositions, and running experience, which can be seen in the table. In the logging of daily experiences, we already gained a few insights. On the first morning after installing Lena, all participants went for a run, curious to experiment how it would work. P2 and P3, who recognized their running routes in the visualization, yet expected it to appear faster. Another element that was quickly noticed by the participant was the different length of the pins. Although participants chose their most important effort, they were not informed the length of the pins would represent this. In the paper, we elaborate more on the results, but in this presentation, I will touch upon some of the results we collected with the study on the data visualization and the shape change of Lena. All participants indicated they started running in different routes than normally, challenging Lena to change shapes to different sides or even outside the center. As we can see in the quotes, the fact of being able to indirectly control the shape change of Lena triggered anticipation right before going for a new run. When talking about the direct interaction, being able to push back the pins, P1 and P3 did not determine beforehand when they would push back the pins, while P2 immediately decided to make it a weekly effort. After eventually pushing back the pins, all participants felt they had a clean slate, which resulted in a new regained curiosity. The fact that Lena gave physical feedback was considered as one of the most appreciated elements by all the participants. This enabled a shift of focus, where instead of thinking about how you did it, you realize you actually did it, which is good on its own, regardless of the performance. When we talked about the slow feedback mechanism Lena enabled, we see that in the study at first, all participants expected the feedback to be fast and instant. However, P2 and P3 specifically valued the slow and delayed timing, because the feedback would come in phases. This way, they were more often reminded of their previous effort and it felt rewarding. To conclude, in this paper we present Lena, a shape-changing art piece acting as a slow feedback mechanism for recreational runners. In our study, this dynamic feedback allowed for longer reflection, anticipation, and exploration of running behavior. Through this, we explored how dynamic data visualizations can open up the design space of outdoor exercise feedback and inform how to design for a slow feedback mechanism in the running context. Thank you for listening, and I hope this was an inspiring presentation.